All right, so this is 2.1 quadratic function notes for Wednesday, Thursday, next week, 9/16, 9/17, and your homework problems are page 120, 13 to 45 odds. I want to make you aware that we are not going to Zoom this Friday, which is the 18th, September 18th, because I have to go to an AP calculus conference, so I will not be around Friday to Zoom. Okay, so on this quadratics, we've already done quadratics, but we're going to do something a little different today. And the main thing that we're going to be doing different is we're going to be doing the standard form of a quadratic equation, which is also known as vertex form, because you can find the vertex right from this equation. So this right here is called the definition of a quadratic. It's also known as the general form of a quadratic. General. And that is if this thing right here were to equal 0, that'd be the general form. But we are going to come down here and we're going to put it in this vertex form because we can find the vertex right from this form. If you notice in this equation, we have an x minus h. The h, if you look down here where x equals h, the h is going to be the x coordinate of your vertex. And so if you notice here, it's a negative h, but here's a positive h. So we're going to be changing the sign of the h. And then this k is going to be the y value of the form. Some books, and we're going to do this later, some books write it in this form, and instead of an a here, they put a 4p. And later this year, we are going to do this also because this is part of what's called a conic section. I'm just kind of giving you a preview of how else we're going to write this. It's going to look like, if I make a square there, it's going to look like this. If you notice, all we've done is take that k over there with the y because f of x and y are the same. So this is the same formula, except now we're going to put a 4p here instead of an a. Right now we're going to use a, later we're going to make it a 4p, and you'll understand why when I teach that later. Okay, so first of all, what we need to know is this point right here is called the vertex. That's either going to be the minimum point, or if it's over here like this, that's going to be the maximum point. And this point is going to be the letters HK. That's where that comes from. This HK is going to be the ordered pair for that. Same here, that is HK. Now, so going back over here real quick. So what we're going to be doing is we're going to be finding vertex. We're going to be putting in standard vertex form, and we're going to sketch the graph. We're not going to really be finding min max, except that they are the vertices. So we're going to find those vertices. And another thing you're going to have to do on this test is get the axis of symmetry. So this red dashed line right here is called the axis of symmetry because it cuts the parabola right in half. And here's an axis of symmetry. Now we abbreviate axis of symmetry in this class when you see this. Axis of symmetry. When she makes this test, she abbreviates this AOS. That stands for axis of symmetry. So you're going to have to find that, and I'm going to find that on a couple of problems today, even though it's not asking me to. So I'm supposed to take this general form of an equation, and I'm supposed to write it in standard form, which I put vertex because you find the vertex. And then we're going to name the vertex. We're going to get the axis of symmetry, and we're going to find the x-intercepts. So I'm going to do this problem right now. So step one is you're going to rewrite this, but you're going to put some space between the second term and the third term, because we are going to have to add a number here to do what's called complete the square. So the first thing that you have to do to complete the square is you have to take where the b is. Normally quadratics, I'm going to write over here is ax squared, and this should look familiar to you, plus bx plus c. That was what was on that other screen. So the first thing you're going to do is take half of whatever b is. You're going to take half of that, b divided by 2, and you are going to square that. And we're going to add this number here and here. So when I do that right here, I'm going to take 16 divided by 2 and square that. Well, 16 divided by 2 is 8, and 8 squared is 64. So I'm going to add a 64 right here. So I'm adding 64 to complete the square. And so over here, I have to subtract a 64 because whatever I add, I have to subtract to keep it equal. So this is total of 0 here. Now, the second step, once you complete the squares, you're going to write a binomial square. We are going to factor this trinomial into a binomial square. In other words, if I were to write 2 sets of parentheses and factor this, this will factor to the same thing twice. So we're basically writing this down as a square. Now, here's how you do that. You take this first term and you square root it. And you ought to be writing this stuff down in your notes. You square root x squared, which is x. You take this number and it goes over here, and you take the square root of 64. You square root that one. And that is 8. And whatever this sign is up here, you take that sign and that sign goes down here. I hope you see that's x plus 8 and x plus 8 twice. Then you add these two numbers and they give me -3. And I have just put that in standard form. So the standard form, again, looks like this. So from this, I can get my vertex. My vertex is HK. Well, H is the opposite sign of this. So H is -8, and K is the sign of this that's kept the same. So my vertex is -8, -3. Now there's an A value of 1 here, and something I didn't tell you that's written in there. If this leading number is a positive, this graph will open up. If this leading number is a negative, this graph will open down. But there's my vertex. Your axis of symmetry is going to be x equals whatever the x vertex is. And the reason that's the case, if we go back here and look at this picture, the vertex always goes right through, or sorry, the axis of symmetry goes right through the vertex, and it's always x equals because it's a vertical line on these. So you must put x equals on those. So that's the axis of symmetry. And then we are supposed to find the x-intercepts. Well, the x-intercepts occur where y is 0, just like they always have. So we're going to do the same thing we've always done. We're going to stick 0 in for y. And then I'm going to write down my standard form like this. And now I have to solve this for x. So I'm going to add 3 over. And in order to get rid of a square, we are going to square root. And I hope you remember, you got to put plus or minus when you square root a number. So the square and the square root over here cancel out. So that gives me x plus 8. And over here I have a positive and a negative radical 3. The last thing I have to do is subtract that 8 over. So x is going to equal -8 plus or minus radical 3. So those are two different x-intercepts. One x-intercept is -8 plus radical 3, and the other intercept is -8 minus radical 3. That plus and minus means that's two different things. So these are the two x-intercepts right there. Now I'm going to do another problem over here like this, because this is the hardest kind, because again, the leading coefficient of the x squared, that's the quadratic coefficient, is not 1. So when you have a problem like this, you have to factor, and this is really difficult, you have to factor out the 2. You have to get this to be 1 first. So you're going to factor a 2 out of front, and you have to take that out of both the x parts. So this is pretty hard. So what I'm going to do is I'm factoring a 2 out of this. That means I'm dividing this 1 by 2. So that actually gives me -1/2 x right there. So dividing 2 by 2 gives me 1. Dividing 1 by 2 gives me 1/2. Now I have to take that 1/2 and divide it by 2. Well, dividing by 2 is the same as multiplying by 1/2. So what that means is I've got 1/2 times 1/2, and I'm doing the same thing I did over there, and I have to square this. So this is 1/4 squared, which is 1/16. So I have to add 1/16 right here. So I tried to pick one of the hardest problems to do for you to help you out with this. Some of them, a lot of them don't have any fractions, but I wanted to do a hard one. Now, this is also very difficult. And the reason this is very difficult, and maybe I should have put this as a black one because it's what I'm adding on here. Because if you notice over here, what I added there, I had to subtract there. Well, it's the same story, but the problem is it looks like I'm adding 1/16, but I'm really not because this 2 is a distributive property in there. So I'm really adding 2 times 1/16. So this is pretty tough. So 2 times 1/16 is 2/16, which is 1/8. So that means I've actually added 1/8 over here. So over here, I must subtract 1/8. Now, when I combine these terms over here, I'm going to make this 1 into 8/8 because I got to get common denominators to subtract those. So when I come over here, I get 2, and this again factors to a binomial square. Over here, 8/8 minus 1/8 is 7/8. And in here, you take the square root of x, goes here. You take the sine of the middle term, goes here. I'm doing the exact same thing I did over here. And the square root of 1/16, well, the square root of 1 is 1. The square root of 16 is 4. So there is my standard form. Now, this is very hard. So right now, I can get my vertex. My vertex is the opposite of this. So that's a minus in there. So it's a positive here. And you keep this one the same. So this is 7/8. So there's your vertex, your axis of symmetry. Is always x equals whatever that x is. And then I'm going to plug 0 in here and solve this thing. So this is going to be ugly because I got fractions. So I get 0 equals 2 times the quantity x minus 1/4 squared plus 7/8. Oops, not 78, 7/8. So I'm going to subtract 7/8 over. And I have to divide both sides by 2. So when you divide this by 2, that's the same as multiplying by 1/2. So since this is a fraction, I'm going to multiply by 1/2, which is the same as dividing by 2. I hope you all see that those 2's will read. Square root this side. So I put a plus minus here. And it just so happens when you square root a negative, this is Mr. Downing's friends. It's imaginary. So this would have no x-intercepts. In other words, the graph would not cross the x-axis. So that's those two problems. Now that fraction stuff is pretty crazy hard. So I hope you are okay with what just happened because, like I said, this is difficult stuff. All right, we're going to go on to the next problem. This is number 28, and this says do the same thing with your graphing calculator. And what I meant to do is type this in before I started the video, and I did not do that. So I'm going to type this into my graphing calculator right now, and then I'm going to show you how to do all this stuff on your graphing calculator. And you got to use the negative sign, not the minus sign, because if you hit the minus, it'll give you an error. It'll say format error or text context error or something along those lines. Okay, so I'm going to put the screen so you can see this thing. And then I'm going to show you how to do all this stuff on your calculator because it's pretty amazing what these calculators do. So zoom in here so we can see it. And I'm going to tell you the buttons to push, and you need to practice this or it's not going to work. So I want you to be able to see that I typed in the problem just as it showed me on the problem, and then I'm going to hit graph. So here comes this graph. Now you can't see the whole thing, right? I hope you can tell that the vertex is up higher. So I'm going to change my window and I'm going to make my Y higher. And because there was a 30 out there at the end, I'm going to go up to 50 just to make sure I can see the top of the graph. So there's my graph. Now, if you recall, I told you earlier that the vertex is also known as the max or the min, and in this case, it's going to be the maximum because it's the highest point. So we can find the maximum on this graph. So I'm going to hit second trace, which is calculate, and if you look at number 4, it says maximum, so I'm going to hit number 4. Now this says left bound down here. That means I have to get this little thing blinking, that cursor, to the left of the max. So I'm going to go left of the max. I can tell that's gone down, so I'm going to hit enter. And now I've got to get to the right side of the max. So I'm going to go up. And you can watch this Y value here because it's going to go up, and then it's going to start going down again. And then I can tell that it's going down, and I can hit enter again. So I just told the calculator that between those two dashed blue lines, I hope you can see them. I don't know if you can or not, but there's two lines going down here. There's a max there. So all I do is hit enter the third time. And right down here is my maximum point, which is my vertex. Okay, so there is my vertex. So I'm going to go back to my screen up here, and I'm going to write down that vertex because that's going to help me write my equation. Moving this out. So I just found on my calculator that my vertex is negative 0.5 and 30.25. So what I can now do is I can say that f of x is going to equal negative, because it's opening down and there's a negative there, so this stays negative, and then I'm going to have x. Now remember, this is my h right here, right? That's my h, so I have to change the sign to plus 0.5. Okay, and then I got to put my square on there, and then this is my k, so I come out here and put plus 30.25. And now I can do my axis of symmetry as well. So the axis of symmetry is going to be whatever this vertex is. So it was negative 5, so it is x equals negative 0.5. I think I said negative 5, but negative 0.5. So see, the calculator can help you find those problems super fast if you know the buttons to push. So hopefully you will practice that. I've got one more problem, and I'm going to be done. So the last part says, write the standard form of a quadratic given a vertex. So they gave me the vertex and a point that's on the graph. So here's the point on the graph. And again, I tried to pick a hard problem that had these crazy fractions because I know they're harder. So you need to know that this is x and this is y. Well, y is also f of x. So I'm going to plug these four things in where they go over here to find a. So when I do this, my f of x is at 3/2, so I'm going to put 3/2 over here. This a is what I'm looking for, so it stays a. This is my x value right here, so I'm going to put 61 over 10 in here, and then minus h. Well, this is h right there, so it's minus 6. If that would have been negative 6, this would be plus 6. And then I get plus my k, which is 6 over here. Now I have to solve this for a. So I'm not really sure how you would do this. If I make this decimal, it will make it a little easier, I believe. So 3 divided by 2 is 1.5. 61 divided by 10 is 6.1. And now I got 1.5 is going to equal a. And then 6.1 minus 6 is 0.1. So now I'm going to subtract 6 from both sides. So it's going to be negative 4.5 is going to equal, and I'm going to put the 0.1 in front of the a because it's actually the coefficient of the a. And then I think I'm going to change this back to a fraction by putting it 1/10, because I hope we all know that you can multiply this by 10 over 1, and these reduce to 1s. So if I multiply this by 10 over 1, it's just 10. So I get a is going to equal negative 45. That's a huge number. So now I can write my standard form, because in your standard form, the x and the f of x is always stays that. So now we're going to plug everything else in that we have. So we get f of x equals, and now that negative 45 goes in for the a. I keep this x, and then I plug in my vertex, my hk again down here. So I get x minus 6 uh-oh, I just made a mistake and I missed it. So I got to come back up here. Do you see I left the square off? So that has to be squared. This has to be squared. So this becomes, and this is squared. So I need to redo this. My A is wrong. I'm glad I just caught that because that would have been a pain to go back and do all again. So when you take 0.1 times 0.1, that is 0.01 when you get that. And 0.01 is 1 over 100. Okay, and then you multiply this by 100, and we multiply this by 100, so it makes it even bigger. It moves that decimal point 2 places, so that's actually 450. And then we put the square back in there and we get to +6, and this is the answer. So I accidentally left that square off, which caused me to make a mistake down here, which caused it to be off. So this is a little bit of a crazy graph, but that would be the vertex form. So I hope you guys have a good one, and I will talk to you in class next time. And hopefully we'll all get this idea when you practice it on your homework. See you later.